Hello students, welcome to my YouTube channels. Today our topic is partial differential equations, which is coming in the Math 3. Under this we are going to study today Lagrange linear equation. Under this we are going to study Lagrange linear equations. So this belongs to unit 1. So already previous video we discussed eliminatory of arbitrary constant and eliminatory of arbitrary functions. So today our important portion is Lagrange equations. So Lagrange equations form will be capital P small p plus capital Q small q r, where P and Q are the function of x, y, z, where P and Q are the function of x, y and z. Then we have to take the subsidiary equations. What is subsidiary equations? Dx by capital P, dy by capital Q and dz by capital R. This is called subsidiary equations. After the subsidiary equations, we will solve the questions either by method of grouping or method of multipliers. When will use the method of groupings? When will use the method of multipliers? See, both method we can use, but what is the concept here? If integration terms will be very small, then we'll go the method of groupings only. But if integrating parts will be very long, complicated, like algebraic expressions, big expressions, then we'll go the method of multipliers. So first I'm going to discuss today method of groupings. So method of groupings, first we are seeing the subsidiary equations. A 1, 2, 3 equations there. If we'll consider first two, that means dx by p equal to dy by q. Then we will see here, z terms in the p and q, x and y, then z terms should not be there. Terms should not be there. Then next, if dy by q is equal to dz by r will take, here we'll see x terms should not be there. If here z terms will be there, we'll eliminate first z terms. Then only we'll integrate this and this, like dx, whatever p will be there, whatever y will be there, we'll integrate. Here also y and z is there. So x terms should not be there, and we'll integrate. So once we'll integrate this, we'll get some, see, x equal to y plus c. So x minus y is equal to c1, give c1. So this will u is equal to x minus y, one terms will come. Similarly here, if we'll integrate, what will come? Y is equal to z plus c2. So y minus z is equal to c2. So v is equal to y minus z. So what is our solutions? U comma v equal to 0. This is the method to solve the method of groupings. That means, what is the denominator here? If denominator will be very small terms, then we can integrate easily and we can write this terms. This is the form for method of grouping. So what were the method of multipliers? Method of multipliers, no, same subsidiary equations will use. Suppose first we are using the multipliers L, M and N. Using the multipliers at L, M, N. So what will be the equations now will become? L dx plus M dy plus N dz divided by PL plus MQ plus MQ. So just we'll rub it this way. This will be the MQ plus NZ and R. Using the multiplier, that means using the multipliers LMN, now will become like this term. Now what we have to see, the denominator term PL plus MQ plus NR should come 0, or we have to make 0 like this. Multipliers will use and denominator terms will become 0. Once will come 0, then L dx plus M dy plus N dz also will come 0. Then we'll integrate both sides. So L dx plus M dy plus N dz equal to integration of some integration of other parts will come constant C1. If you integrate this, it will come C1. So integration of constant will be constant. So Lx plus mz my will be my plus nz equal to C1. So this you write here 0 only. So integrating both sides now it will come C1. So this one terms came. Again using the multipliers L dash, M dash, N dash. Then similar again subsidiary equation will become L dash dx plus M dash dy plus N dash dz. Then here L dash P L dash plus Q M dash plus R nz. Similarly, we'll make this denominator parts 0. These terms will convert into 0. So you will select like this multiplier. So this should become 0. Then again, what will be there? L dash dx plus M dash dy plus N dash dz will become 0. So here again we'll get what is L dash x plus M dash y plus N dash z equal to C2. So again what will write here? Phi equal to C1 comma C2 equal to 0. This is the solution. So this is the theorem like you have to remember. Method of groupings, simple terms will go. If complicated term will come the method of multipliers. This is the rule here. Here that only you have to take care x and y is there. Then denominator, both sides, z should not be there. Z term should not be there. If there now, you have to eliminate. Q and R, y and z is there. So x should not be there in the denominator. If there, we will eliminate. So that only we have to careful. Then we'll integrate simple integration, two constant will group together and we'll get the answer. This is the theorem. Now what we'll do, we'll see the simple one problem for both first. Okay. So this I'm going to rub it now. Now we'll take one simple question. First we'll take method of grouping questions. So we'll take first simple questions. In there, yes, px plus qy is equal to z. Problem will be there. Px plus qy is equal to z. Now P, Q, R. So this will come P, Q, R. What is this x, y, z? So capital P nothing but x, capital Q nothing but y, and R nothing but z. R nothing but z. Now substitute the subsidiary equation. Substitute the subsidiary equations. Dx by x, dx by P, so dx by x, dy by y, dz by z. See the small terms will be there. So what we'll do? Group together. So first 1 and 2 will group together. 1 and 2, first and 2 group together. What will come? Dx by x equal to dy by y. Integrate both side. Integrate both side. What will come? Log x equal to log y plus log c1. So what will come? Log x minus log y is equal to log c1. So what is there? Log a minus log b nothing but log a by b. This is the formula. Log a minus log b is equal to log a by b. So similarly we can write here log x by y equal to log c1. Then you can write here finally x by y equal to c1. So this you keep it first over. Now consider 1 and 2. Now this consider 2 and 3. Consider 2 and 3. So what is 2? dy by y equal to dz by z. Integrate both side. Integrate both side. What we will get? Log y is equal to log z plus log c2. Because c1 constant I given here. So take another constant c1. Similarly you can write here log y by z equal to log c2. So y by z equal to c2. Then final, what is the solutions you will write? You will write phi x by y, comma y by z equal to 0. This is the solutions for this. This is the solutions for the partial differential equations for this problem. So see here, small terms will be there. We got the method of grouping. Now we'll take little bigger problems. Okay, you come this side. So we'll take one more problem. Method is okay. Y square z. So another problem number 2. Y square z by x. This is given small p plus xz. Xz is small q equal to y square. They given like this. So again, this is this format. We have to check this Lagrange equals format is there or not. This part they given p, this part q, this part r. P, q, r. So what is capital P is equal to here? Y square z by x. Capital Q is equal to nothing but xz. R is equal to nothing but y square. Rz nothing but y square. Now from the subsidiary equations we'll substitute. What is dx by y square z by x equal to dy equal to xz equal to dz equal to r, that is called y square. Now look here, 3 group is there. Now which group will select? Suppose you are selecting first 2. First x and y. Here x and y, z will be there, but z will be there both sides, so it will get cancelled. That one, what I told here, method of grouping. First confirm x and y, z should not be there, but z both sides is there, it will get cancelled. So okay, consider first 2. Consider first 1 and 2. So what is there? Dx, so x will go top, x, y square z is equal to dy x xz. So z get cancelled. So okay, xz will get cancelled. So what we can write here? X square dx equal to y square dy. X square dx cross multiplication, this will come. Now integrate both. So what will come integration? X square, okay, you write here, integrating both. What will get here? Integrating both. Now what will get? X cube by 3. I am writing here. X cube by 3 equal to y cube by 3 plus some constant. You give C1 by 3. Why I am writing 3 now? Suppose you will take the LCM. Why I am writing C1 by 3? Suppose you will take the LCM. What will come? X cube minus y cube. If you will bring this side, x cube minus y cube by 3. If only will write C1, then 3 will come here. So 3C1, again another constant we have to use. Otherwise see 3 is there, 3 get cancelled. So due to that only we are taking C1 by 3 here. Okay, so directly what we can write here? X cube minus y cube equal to C1. X cube y cube minus C1. This is first course answer came. Now I will rub it this side. Second part, this first method of grouping over. Now second part you see here. Second part you'll see. Suppose you don't know which one will take. Suppose you are taking 2 and 3. See what is happening. 2 and 3. What is happening? Xz. 2 and 3 are taking now. What is happening? You see here. Xz equal to dz by y square. Now what I told? Y and z. X should not be there. I told the derivation. Y and z. X should not be there. But x is there. Here x not there, so it not get seen. So these relations we cannot solve this question. Then what will do? You take some other 1 and 3 or 1 and 2 taken. No, 1 and 3 you take. You will see this dx by y square z by x equal to dz by y square. I taken which one? 1 and 3. 1 and 3 relation. This is 2 and 3 taken and not possible. Why not possible? Because y and z, x should not be there. If x na both sides should then get cancelled, but only one side is there, so we cannot integrate. So now here y square get cancelled, z and x dx we can write here x dx equal to z dz. Now we can solve. So integrate both sides. So x square by 2 is equal to z square by 2. Z square by 2 plus C2 by 2. So x square minus x square minus z square is equal to C2. Another part. So we can write phi is equal to x cube minus y cube, comma, then x square minus z square equal to 0. This is our solution. This is our general solutions for the Lagrange equations under method of grouping. So this way we can solve the method of grouping problem. So okay, now we'll take one method of multiplier problems. Okay, then next video again we'll continue some more method of group multiplier problem, but at least one will take today here. Okay, so this way 2 answers you got. Okay, now I will rub it this side. Now we'll write one questions method of multipliers, how we'll use. So questions they will give, find the general solutions of the partial differential equation. Questions they will give y square minus z square minus y square. Z square minus y square is small p plus x square minus z square is small q equal to z y square minus x square. This term the given. So look here, P and Q is there, P and Q and R. So this is called Lagrange linear equations format. But see this, what is here P first, capital P you search. This is the question. This is the questions given. Now P, what is the P here? Apart from this P, this is the capital P. X, z square minus y square, nothing but P. What is Q? Apart from the Q, what is there? X square minus, here something will be there, y missing, plus y. P, again check, x, z square minus y square P, then plus y, x square minus z square Q and z. Okay, like this. So here Q is equal to y x square minus z square. Then what is R? Z y square minus x square. So method of grouping if we'll do, very tough to integrate. So if we'll substitute the subsidiary equations here, okay, substitute and you'll see dx by p. What is p? X z square minus y square equal to dy. What is there? Y x square minus z square. Then do z y square minus x square. So if we'll go the method of groupings, so it complicated to integrate. So that's why we'll go the method of multipliers. Method of multipliers, what I told, if we'll select any one multipliers and like this, such that denominator should be 0. So now look here, what is there here? Z square y square, x square z square. So z will get cancelled, y will get cancelled, x will get cancelled. That means if we'll multiply here x y z, see here, if multiply using the multiplier x y z, using the multipliers, using the first multipliers, what will happen? So just to see this here. So x dx plus y dy plus z dz. We'll see what is happening. We'll see. Now x square. X here. So x square z square minus again x square y square. So first multiply x here. So x square z square, x square y square plus second y. So y square x square x square minus y square z square. Third one z. So z square y square minus x square z square. Now look here, x square z square minus x square z square, x square y square, x square y square, y square z square, so got 0. That means this becomes 0. Then x dx plus y dy plus z dz equal to 0. Integrating both sides, what will come? Integrating both sides, what will come? X square by 2 plus y square by 2 plus z square by 2 is equal to some constant c1 by 2. Then finally what we can write here? X square plus y square plus z square is equal to c2. So this c1 this is called c1, first constant we got now. So first multipliers we over. Okay, now this I will rub it. Second multipliers you see here. Now again what we have to see? Seeing this we can identify. X square we multiplied now, got 0. Now suppose only z square y square, this will add na, it will get 0. So x has to remove. So what will use? Use the multipliers 1 by x1, 1 by x1, 1 by y1, 1 by x, 1 by y and 1 by z. So see, if you will divide here numerator and denominator, what will happen? Or x dx by x plus dy by y plus dz by z, divide by, here also divide x, y, z. So what will get here? Using the multipliers 1 by x, y, z. Okay, so what we will see, what is coming here? Z square minus y square plus x square minus z square plus y square minus x square. See, everything will get cancelled. Everything will get cancelled. So 0. Then what will happen? Dx by x plus dy by y plus dz by z equal to 0. So integrate both sides. What will happen? Log x plus log y plus log z is equal to c1. Log c1 you can write because log is there now. So constant we can assume log c1. So x, y, z log equal to log c1, because log x plus log y plus log z you can write log x, y, z. So x comma y comma z is equal to c2. c1 already there wrote there, another constant you have to write c2. So what is solutions? Phi c1 comma c2 equal to 0. Then phi these two terms you write, this will be the answer for that. Okay, so method of multipliers, what you are seeing here, if you see the denominators, big expressions will be there. Then our target is to use like this term, select like this multiplier. So denominator once you are adding, it gets 0. Once denominator 0, numerator just integrate and get the two constant and find the general solutions of the partial differential equations of the method of multipliers. Okay, so some more problems I will solve in this method of multipliers. Then we'll go to our linear differential equations for the next class. Okay, students, thank you. Subscribe to the channel. Okay, thank you.